Hello and welcome back to Let's Code Physics. Today we're going to continue developing our self-driving car simulator. We're going to focus today on this loop that we had last time, where one of our cars had this weird turnaround. I have not seen that reproduce yet, so I'm still trying to figure out what the deal with that is. As soon as I find out what that is, I will report back and report the fix for it. I suspect that that's going to get addressed as we refine the trajectory generator for the car. Speaking of trajectory generation, let me start this over so that we can see it. What you'll notice is I've gotten rid of the jagged lines in the car's trajectories and the center line that they're following. The way I fixed that is I now have a center line being calculated for the entire loop. So for the entire lane, it's calculating a center line, and the cars are just reading in that center line rather than calculating it for themselves every time. They're just reading it from it already existing. What you'll also notice is that I've got one car, this guy here, traveling faster than this car here. So this one is traveling at the speed limit. This one in front is traveling at half the speed limit. And of course, that's leading to a collision here. Oh, that's terrible. So what we are going to do today is make it so that the car that is traveling faster adjusts his speed based on the car that is in front of him. I've currently got it set up to where the car can detect, I guess this is the fast one, to where this car can detect that there's a car in front of it. If you look, when it swings around this corner, then the slow one will be in front of this one, and we'll get a car in front message right here. There we go. Good timing. But it stops registering it. So you notice I've only got 19 of them. It stopped registering as soon as this car went around the corner, because right now it's not seeing the car in front of it. It won't see it in front of it again until it reaches here. And that's obviously a bit too close to be realizing that there's a car in front of you, because technically the car is in front of it, even when it's around the corner, because it's along the same center line that it's traveling. So what we are going to do today is we're going to modify our code so that the car that's traveling faster can see around the corner, and then we'll modify it so that it adjusts its speed accordingly, because right now it's just saying there's a car in front, and it's not doing anything with that information, which is not terribly helpful. So let's take a look at what we've got set up so far. So this is in the determine goal subroutine. So this is where the car is determining what its motion goal needs to be. Just ignore this little block about test car for right now. We will turn that on in just a moment, meaning toward the end of the video. So what we're doing is we're evaluating this Boolean car in front, and this is just asking the question, is there a car in front of me that I need to be concerned about? So the way we're doing this currently is we're using this function called Raycast. The way Raycast works is that it shoots a ray from in front of the car. So you imagine that this is the car that's doing the looking, and this is the car in front. So the lane traffic is going upward in this case. The way Raycast works is it shoots a ray from the car, and you can shoot it in any direction that you want. So currently we have that ray starting at the position of the car. So it's starting at the car's center, and it's going in the direction of the car. It's being set up as vector3.right, but we're using the transform direction to say it's right for the car, because these cars are set up to go so that forward is the right direction, or going along the lane is the right direction for them. And so basically this ray shoots out and looks for any game objects that it intersects with. Specifically, it's looking for any game objects that have a collider attached to them, which is true of the other car. And so as soon as that ray hits this car, it registers that and then returns that game object in this information called hit. So this hit is the object that the Raycast hits, and here we're looking for whether that object is a car. Because there might be other objects in the scene. There might be building, there might be a road obstacle, there might be a chicken, but that's going to require different behavior than just having a car in front of you that's going slower. That's a rather different event than having a chicken crossing the road. There's also these lane game objects in the way of the ray. So we've added those to the layer Ignore Raycast, which is this wonderful built-in layer in Unity that will ignore any Raycast looks. Basically, this layer is transparent to the Raycast. It's pretty handy. It's made life a lot easier rather than having to say, okay, ignore it if it's a lane, ignore it if it's a lane. So now we're only looking for cars, basically. So the current setup works fine if we only have a straight road, but if we have any kind of turn at all, which we do, and which we should be able to account for, then the car behind is not going to see the car in front until it's a bit too late, as we saw earlier. And so what we need to do is we need to change this Raycast to no longer just go straight ahead. Obviously the car needs to look straight ahead, but it also needs to look along the center line. So you imagine that we've got the center line going along this way. So this is currently the path that the car is following. What we need the Raycast to do is we need the Raycast to go from the car, so it's always going to start at the car, but we need it to sweep around to every point along the center line, within some specified safety distance, some look ahead distance or something. And so basically what we need to do is we need to set up a loop, and we need to have the loop continue until we find a car. And so that's what we're going to start with today in the code. I know I didn't do a whole lot of code building in the last video, so this one will be a little bit more detailed. So what we're going to do is we're going to create a loop that basically swings the Raycast around from the car to each point along the center line. So in order to do that, we're going to need to set up a loop. Let's see. So we want to have Raycast. Yeah, we do want to have. Let's see. I think we want to have that declared outside the loop. Yeah, this ought to be fine. So here's how we'll do this: is we'll try to look for a car in front. So we only want to run this thing while we haven't found a car in front. As soon as we find a car in front, we need to stop it, because that's obviously the closest car. Because our centerline array is nice and ordered now, so I can just I can go along every element of the centerline list, and then just look for the first time it hits a car, or sees a car. The array's not hitting the car, it's seeing the car. So let's do this. Let's set up this as while we haven't found a car in front. And we'll want to keep track of where we are in the list, so let's define an integer I point. This will be the index of the current point on the center line. Cool. So while we haven't found a car in front and I point is less than the, let's see, what do we call our center line list? I think we just call it center line. Let's see here. What do we call that? We call that one... Oh, no, it's going to be an update. My bad. Yeah, we call it centerline. Okay, that's what I thought, but I've been working in a couple different subroutines with centerline. So we want this to be less than centerline.count. I suppose I could have just started typing and see if it came up. So while these two are true, so in other words, if we haven't found a car, and while I point is less than centerline.count, meaning we still have points to look at, we want to continue forward. So all of this needs to come under the while loop. Let's see here. Yeah, there we go. Let's tab all those in. Cool. And so what we'll do is we'll set up the ray. We're calling it ray look. So again, it's going to start here, but it needs to go to the next point. Actually, why don't we have... let's see. Yeah, let's just get rid of this part where it's looking to the right. We'll just have it go to the next point in the center line. So we'll say center line of I point. Cool. And then we need to do the okay, yeah. So we're doing a debug.drawRay here. What this just does is it displays the ray we're looking down. This will be taken away for the final version of the sim. This is just a diagnostic to show us the ray. Let's see. So we've got our car in front equals physics.raycast, ray look out hit. So physics.raycast returns true or false whether it sees something. And so this is basically storing whether that's true or false. And so here, if it did see something, so right now car in front just means did it see something. So, did it see something? If it did see something, then we're going to check whether it was a car. So this is checking, did it see a car? The next thing we need to check is whether that car is actually in the same lane as the car. Because you imagine if we had another loop over here, and there was a car off to here. Actually, I suppose there's an easier way to check that, because I can specify the maximum distance that this thing looks down. Oops, not under Ray, under Raycast. I can specify the maximum distance, although I haven't had a whole lot of luck with that working with the out.hit. So let's maybe check the car's lane. So here we'll check, is the car in my lane? And actually, I suppose I want to do that... no, let's do that within here, yeah. So we'll say if car in front. So we'll just keep using the car in front. And basically, car in front is going to become false whenever we discover it's not a car to be concerned about. So here we're going to check for, is the car in my lane? Because if it's not in our lane, we're not going to be worried about it just yet. Obviously, if a car is careening out of its lane and into ours, then we need to be worried about it, but we'll build that scenario another time. So what we need to do now is we need to look at this object that was hit. So we're looking for car in front to be equal to... Let's see, how do I need to do this? I need to do this as hit.collider.gameObject. So that returns the original game object. And then I need to get its which lane component, because that's the subroutine that stores which lane we're in. Dot get component which lane. Actually, why don't we store this as another variable, because it's getting cluttery here. So we'll say new other lane equals this. Is that how I need to set that up? How did I set that up here for my lane? I had to look for WL equals GameObject.getComponent which lane parentheses. Cool. So that is how I need to set that up. I can even confirm that. Oh, that's right. It doesn't like when I declare a new other lane and then have it equal something. Oh, right. I need to have this be a new which lane. Other lane equals this, although it's not going to like that. So we'll have other lane equals this. All right, I'm getting a red squiggly for other lane. Oh, right. I just need to have... Right, how do I set that up? Let's see here. Oh, it needs to be lowercase. Right, will that turn you blue? It needs to turn you blue. Why are you not turning blue? Well, let's see if it gives an error in the compiler. Okay, let's see, how did I set that up here? I set it up as a private, so that... Okay, let's see. Now I've lost where I was. Okay, which lane, other lane. I need it to be an instance of the class which lane. All right, let's forge ahead and hopefully it'll tell me where I'm wrong. Other lane equals, yeah. So that's the which lane. Car in front, other lane dot my lane. Question is that equal to which lane dot? How did I access? Oh, I accessed my lane through ML, I think. How am I storing my lane? Okay, we are storing that as WL dot my lane. Okay, storing that as WL dot my lane. Okay, so this is the other lane that belongs to the other car. This is my lane, which belongs to me as my car. And so that answers the question of, is the car in my lane? So that closes up that closes up that. So then we can print that there's a car in front. Okay, so forgot a semicolon. So let's run this as we've got it now and see if we get the appropriate car in front message when the car is around the corner from us. Oops, I never closed up my while loop. Oh, in fact, I never finished my while loop, did I? So we want to say then that I point plus plus. There we go. Okay, now my while loop is complete. My compiler is going to stop complaining, unassigned, blah, blah, blah. I thought I had that in here. Oh, right, this needs to have a value. Oh, right, it needs to start at 0, doesn't it? There we go. Okay. Error go away, error come back another day. There we go. Okay, let's see what we get here. Okay, cool. So, ooh, isn't that fancy looking? So right now, we've got all of these center lines, we've got all these raycasts flying off. I'm not entirely sure where that's going because that is not the direction of the center line, although this is the first frame. So I think there's something wonky going on with the center line in the first frame. So let's let it iterate forward a little bit more. Okay, cool. So here you can see where the center line is going. So it's sweeping out along each of these. So it's doing all that within a frame. So I guess we're only seeing the last one. It's getting cast forward this way. It does not yet see a car in front. So it saw a car in front in the first part. So actually, why don't we even clear that? Let's see here. So let's see at what point it sees the car. So right now the center line is moving along here. It's almost intersecting with the car. Okay, at that point it's definitely intersecting with the car. Oh, I wonder if I ruined it by hitting clear. Let's see. Okay, so let's look for when this guy sees the other car. Okay, cool. So it sees a car in front at this point. Even though it's facing this way and this car is over here, it sees the car around the corner there. So we should see this number continue to grow because this is the number of times that the system has printed this message. Cool. Okay, awesome. Now let's see it continue to grow because this car is now around the corner. This is the scenario that we wanted to test. Okay, you see now that this number is growing, even though this is around the corner from here. We're getting this raycast. Yeah, you can even see the raycast at the end here is going around here, and it's looking around the corner, and it's intersecting this car here. I guess there's a way to make these raycasts, to make the ray draw longer. The raycast itself is going infinitely far away. It basically goes until it hits at the first game object. at least first game object not in ignore Raycast. Oh, now that's interesting. Now it's not giving me a car in front, even though it's directly in front of it. So my Raycast is going off in the wrong direction. I'm not entirely sure why that is. Okay, I found my mistake. I only made this center line of eye point, so it's looking... it's taking that coordinate as a vector, which we shouldn't be doing. We need to be looking at the next one. So actually, I do need that to be minus transform.position. I did not finish that part. It worked surprisingly well. Okay, that should fix that. So let's try this again. There we go. Okay, cool. So let's let these folks run. Okay, so it is seeing a... Let's see. It saw a car in front in the first frame. It hasn't seen it again since then. So basically now we're looking for when this intersects with this. Okay, so that explains a bit. Okay, cool. So as soon as... Oh, this is great. As soon as the center line intersected with the car, we got this. That's because now we are actually looking in the correct direction. Hooray. What happened to my Raycast? Oh, that's right. My Raycast show up in the scene view, not in the game view. Okay, yeah, cool. So right now it's looking, so for example, right now it's basically drawing these lines from here to every point along the center line. So it's going from here to the point in front, then to another point, then to another point, and it's looking all the way around this turn. If you look at these directions here, it's looking all the way around this turn. So is this one. This one is looking all the way around this turn here. And so as we continue along, we continue to say, I see a car in front, I see a car in front, and it's also in the same lane, so that is good to know. So the next thing that we need to do is we need to put in the command for the car to stop. But I think I've been recording for about 20 minutes now, so minus cuts. We're probably at about 15 minutes, so that's probably good for today. Next time we'll continue along to our next part and actually have our faster going car stop or slow down in time to avoid a collision with the slower moving car. So thank you so much for watching. I will see you next time. Bye-bye.